Every single time a plane lands, something almost impossible happens. A metal machine, weighing up to 400 tons, screams toward the ground at over 170 miles per hour, and the only things standing between you and catastrophe are a handful of rubber tires. They don't explode, they don't even wobble. But why not? The answer is not what most people think. Segment 1. The scale of the problem. Let's put this in perspective. A 500-ton aircraft touches down at over 150 miles per hour, and it's rolling on tires not much bigger than those on a large truck. When those tires make contact with the runway, they go from zero rotation to matching the speed of the aircraft almost instantly. That's the smoke you always see at touchdown, rubber burning against tarmac in a split second of violent friction. A commercial jet typically has around 20 tires, and each one of them must handle forces that would destroy any ordinary tire in milliseconds. So, what makes them different? Segment 2. The construction. Airplane tires are not car tires scaled up. They are an entirely different category of engineering. They are constructed using a combination of proprietary synthetic rubber compounds, along with aluminum, steel reinforcements, and nylon and aramid fabrics. Aramid, that's Kevlar, the same material used in bulletproof vests. The tires are made from at least 3 layers of rubber, each layer laid down in a different direction. This cross-ply technique means the tire resists deformation from multiple angles simultaneously. Each tire is designed to carry loads of up to 38 tons and endure landing speeds of 170 miles per hour or more, surviving over 500 landings before needing replacement. That's not just rubber, that's a weapons-grade engineering feat wrapped around a metal wheel. Segment 3, the pressure secret. Here's the part most people never think about. Typical pressures for commercial aircraft tires range from 150 to over 200 pounds per square inch, compared to just 30 to 35 pounds per square inch for car tires. That's 6 times the pressure. So, you'd think that makes them more likely to pop, right? Actually, the opposite is true. That extreme pressure is what keeps the tire rigid and capable of holding its shape under massive load without deforming sideways or collapsing. But here's where it gets clever. Aircraft tires are usually inflated with dry nitrogen to minimize expansion and contraction from the extreme temperature changes experienced during flight. Nitrogen doesn't contain moisture, so it promotes consistent pressure. And critically, nitrogen is a non-flammable gas. The requirement to use nitrogen instead of air was prompted by at least 3 cases in which oxygen in air-filled tires had combined with volatile gases from an overheated tire and exploded. So, the gas inside the tire is a deliberate safety choice, not just a technical detail. Segment 4. The fail-safes. But what if things go wrong anyway? During emergency landings, tires are built to deflate rather than explode using fusible plugs that melt at high temperatures to release pressure safely. Think about that. Engineers anticipated the worst-case scenario, a tire overheating beyond its limits. And instead of hoping it holds, they designed it to give up gracefully, controlled deflation instead of catastrophic explosion. The tires don't work alone either. The landing gear system absorbs massive impact forces using hydraulic shock absorbers called oleo struts. Without them, every landing would feel like dropping a refrigerator from the sky. It's a whole system, tires, hydraulics, and structure, working together so that no single component has to carry the full burden alone. Segment 5. The testing. And before any of this ever touches a runway, it's been tested to the absolute limit. Tests have shown that airliner tires can sustain pressures of up to 800 pounds per square inch before bursting. 4 times their operating pressure. During these tests, tires are filled with water rather than gas to prevent the test room from being blown apart by the energy that would be released. Read that again. The test room would be destroyed by a bursting tire if gas were used. That's how much energy is stored inside one of these things. And they are engineered to never release it accidentally. So, the next time your plane touches down and you feel that bump, maybe even see a little smoke drift past the window, you're watching one of the most quietly remarkable achievements in engineering. Not just rubber surviving friction, not just pressure surviving weight. It's nitrogen chemistry, Kevlar construction, fusible safety plugs, cross-ply reinforcement, and hydraulic dampening, all working in perfect coordination every single time for hundreds of landings, in temperatures ranging from desert heat to sub-zero cruising altitude. Airplane tires don't survive by accident. They survive because someone thought of everything.